Hello and welcome to Chevolution, enriching minds many at a time. Today's topic is reaction calorimetry and its application in terms of process safety. So, what is the purpose of reaction calorimetry? It is used to determine the heat of reaction, rate of heat generation, and thermal accumulation inside an exothermic reaction. It is useful in the determination of maximum temperature of synthesis reaction, criticality class, and adequacy of cooling required for the exothermic reaction. So how does it work? So it operates in semi-batch mode. One of the raw material is already present inside the reactor and another raw material is added via controlled fashion through a charging nozzle. The rate is controlled by means of a flow meter, and the temperature, quantity, and time are measured via a test computer. The data is generated and it is plotted in terms of a graph for interpretation and further assessment. What are the types of reaction calorimetry? There are four types: heat flow calorimeter, power compensated calorimeter, heat balance calorimeter, and true heat flow calorimetry in the order of increasing accuracy and reliability. So, true heat flow calorimetry is highly reliable and accurate. So, let us have a look at each of them one by one. What is a heat flow calorimeter? As you can see the equation, Q equal to UA into TR minus TJ. TR is the process temperature and TJ is the jacket temperature. Calorimeter is basically a batch reactor equipped with heating and cooling circulations, and there is material addition inside the reactor leading to a reaction causing exotherm. So to measure the heat of reaction, the parameters that are required to be known are U, A, and delta T. So in the heat flow calorimeter, uh, the procedure of reaction is as such: to reach the desired reaction temperature using a circulator. For example, if the reaction is taking place at 80 degrees centigrade, first the entire setup will be taken to 80 degrees centigrade. Then a pre-calibration pulse is done. So a known value of heat will be input and the temperatures of process side and reactor side will be noted. And from that, the UA for that particular equipment will be measured. And this value of UA will be utilized while uh, calculating the exotherm in the actual batch. So the post after the post calibration pulse, actual reaction of intention is carried out in the calorimeter by addition. The process temperature and jacket temperature are noted, and the heat of reaction is calculated. The drawback of this method is that every time U and A needs to be determined by means of this heat pulse, and they actually change a lot based on the fluid properties and occupancy. Second type is power compensated calorimeter. The procedure that is done is to heat the reaction mass to a particular temperature. Then there is a phase of settling. Once the desired temperature is reached, the heater remains on constant power and circulator controls the temperature to maintain the steady state. After that, it is switched to fixed circulator temperature, and heater power is varied to keep the reactor at desired temperature. So now the temperature profile of the reactor is entirely controlled by means of power which is provided to the reactor. So when the reaction is taking place inside the reactor, the exotherm will generate heat, and to maintain the same temperature, there will be reduction in required current because the current will be supplying energy to maintain the temperature. So when the reaction itself is generating heat, the heat required by means of current will be less. So the inverse value of heater power actually provides the heat of reaction. So this is how the power compensated calorimeters are operating. The next one is heat balance calorimetry. It is similar to our exothermic reactor that we use inside the plant. So if you can see the equation, it might be very known to you, Q equal to mCp delta T, where Q is the rate of heat transfer, Cp is the specific heat of the coolant, T outlet is the outlet temperature of water, inlet is the inlet temperature of water, and losses. This is very simple but not so accurate mode of heat balance of calorimetry. It is very sensitive to heat losses and thus not that accurate. Next is true heat flow calorimeter. This calorimeter actually uses a heating element known as Peltier element of fixed area. Thus, it is not susceptible to changes in the UA because area is fixed and heat transfer is from solid directly to the liquid. Thus, there is no major role of U, and U does not, and it is not affected by means of change in viscosity, fill volume, etc. So, in this experiment, a known heater is used to supply heat to the reaction media, and uh, based on the heat input, the exothermicity is calculated. For additional precision level, the whole reactor is placed inside a liquid bath to measure the temperature very precisely. And entire setup is kept at same temperature as the reactor. So there is no heat losses to to the surrounding. Thus, it is the ideal way to calculate the heat of reaction. Thank you.